Hi everyone, my name is Lingwei Cheng. Today I'll present our work, Heterogeneity in Algorithm-Assisted Decision-Making, a case study in child abuse hotline screening by me and my co-author, Alexandra Chouldechova. Algorithms are prevalent in child welfare systems. Child protective services have been receiving a growing number of referrals every year. As a result, many states use algorithmic tools to triage the referrals, which raises concerns about the tool's accuracy and biases. While there are many rigorous evaluations of these tools, a recent comprehensive survey found that the role of organizational factors in the child welfare system is understudied. Two important factors are caseworker characteristics and workforce turnover, which can affect take-up of the algorithms. Our study contributes to understanding the role of organizational factors in human-AI interactions, with a focus on workers' experience. Specifically, we examine the heterogeneity in workers' reliance on algorithms, their ability to override system glitch, and their response to race, according to experience. We asked three research questions. First, how does coworkers' experience affect their use of shown scores? Secondly, does experience influence workers' tendency to screening a referral, given incorrect displays of assessed risks? Lastly, are there racial disparities in the workers' decisions, given the same predicted risks? We find that senior workers have higher screening rates than less experienced workers. However, junior workers' decisions are more aligned with algorithmic scores, meaning they're more likely to screen a referral given the same risk score compared to a senior worker. We find that the staff overall are more likely to screen a referral if the scores shown are underestimates of the correctly assessed scores. Their ability to mitigate the system glitch is not related to experience. Lastly, we find that the experience is not related with racial disparity, which can be attributed to the effects of the glitch and case characteristics. To answer the question, we conducted a case study of the Allegheny Family Screening Tool, AFST. It was implemented on August 1st, 2016. It is a predictive model built and trained using data from the county's integrated data system. The call screening process works like this. Someone would call and make a referral associated with one or multiple children. A call screener would take the call and they would be able to access all historical records associated with the children, parents, and the perpetrator. In addition, they would see a risk score generated by AFST using these historical records. The risk score ranges from 1 to 20, with 1 being the lowest and 20 being the highest risk. The call screeners would then decide to either screen in or screen out the case. Some referrals are mandatory to be screened in and can only be override with supervisor's approval. Another important context to our study is the glitch. For a time period, the scores shown to the call workers, which we call shown scores, can be different from the scores that would have been generated correctly, which we call assessed scores. This is because some features were incorrectly populated. The call screeners were not aware of this issue. Our study uses data from AFST. We exclude non-discretionary referrals. Since one referral can be associated with multiple children, we wrote up the individual level data into referral data to account for the fact that call workers make judgments about a referral, not an individual. We also have covariates such as demographics, allegation, and views. We used a black prioritized coding for race, meaning as long as one child on the referral is black, the referral is coded as black. We now discuss our methodology. First, we categorize workers into senior, junior, and temp, depending on their caseload and whether they have worked through the transitional period from using no FST to using AFST. In the table, we see that over the entire time period, workers shared similar case mixtures according to the risk scores. So it is not the case that only senior workers can work on high-risk cases. During the time period when there was a glitch, workers also appeared to be similarly exposed to it. We make two important assumptions about our modeling. First, we assume that the control variables we have represent factors that workers could reasonably and effectively use for their decisions. We also assume that unobservable factors do not affect assignment. For example, there may be contextual information that the workers learn from the call that affects the triage of the call, but is not reflected in the structured data. We use linear probability model to model work decisions. We use interaction terms between worker categories and risk scores to capture the heterogeneous impact of risk scores by worker experience. We control for a list of observables that workers reportedly use in their daily work. We also control for time and supervisor fixed effects. This accounts for the seasonalities in reporting and screening practices and the personnel effects from the supervisors. We use robust cluster standard errors at the screener level. This means that we assume a screener's decision in one case may be correlated with another decision they made. However, across screeners, their decisions are not affected by each other. We now discuss our results. We find that conditioned on the same risk scores, senior workers consistently screened at higher rates compared to junior and temp workers. This trend is confirmed after we control for covariates as well. After we disaggregate the trend, we find that junior workers' decisions are more aligned with the risk scores. For example, if the risk score increased by 1 point on a scale from 1 to 20, the case will be about 1% more likely to be screened in by a junior worker than by a senior worker. To put this into perspective, it is not impossible for cases similar in nature to have on average 2 to 5 points difference in risk assessments. This would translate into a 1 to 4% difference in screening rate. Considering DHS receives over 15,000 referrals each year, this amounts to a large number of affected cases. When we look at workers' tendency to override the implementation glitch, we find that overall, the staff screening cases at a higher rate if the risk scores they see are underestimates of the correct scores. This trend is also confirmed after we control for covariates. This suggests that workers may be able to detect underestimation errors more easily than overestimation, or they prefer reducing false negative rather than false positive errors. We find no difference in their tendency to adjust decisions in face of the glitch. Lastly, we look at racial disparity. Here we see that even though there are less referrals associated with Black children for lower risk cases, they're consistently screened in at a higher rate than the white children, conditioned on the same shown risk scores. We also find that children of different races are exposed to the system glitch in different ways. White children are more likely to have overestimated displayed risks. In our modeling, we find that race is not related to the glitch. We find that race is related to the glitch and referral characteristics. After we control for both, we find no racial disparity in worker decisions. In terms of limitation for the overall study, we may underestimate the effect of race to the extent that AFSD can be associated with race, since it's built on historical records. We also don't address how screening behavior impacts the downstream child welfare outcome. Thank you.